Okay, we're going to solve some equations together here. So number one looks a lot easier than what we're used to seeing. And it's a good thing because then we can kind of practice some of our basics as we work. So if we remember what we've been doing so far and how we've handled our equations so far, how we handled them when we were working with the hangers. And I know some of you, the hangers have been really, really helpful. Some of you, you don't need to think about the hangers, but I will come back to them here and there just so that you can have a method when it does get tough to kind of visualize what's happening. So if we think about what we did when we were working on those hangers, is the first thing was to kind of decide what we had on each side. Okay, and that's where the process of simplifying comes in, and in the equations that we've seen get worked, simplifying was always the first thing that was kind of done. So that's what we want to take a look at is, can we combine anything? Can we clean up either side of our equation? So if we look on the left-hand side, I actually have 6 A's and 5 A's. So it would make sense, instead of writing them separately here, why not combine them and rewrite it as 11 A's? Combining like terms. And that's a simplifying step. Now this, you wouldn't necessarily have to always write that. I just made a note there. So if you can imagine the hangers, if I had my original written like hangers, I would have 6 A's grouped here, and then 5 A's here, and then I would have 11 negatives. And if I were to ask you, what was on the left side of the hanger, you probably wouldn't tell me 6 A's and 5 more A's. You would count them all up and tell me that I had 11 A's on this side and negative 11 on the right. So naturally, you would combine the A's and just tell me you had 11. So that's all we're going to do here, is just simplify by combining what we can. Now we want to start solving. So the goal with solving our equations, the final ultimate goal, is to have an A on the variable on one side, a number on the other, okay? But before we can get it down to a single variable, we just want to get all of the variables together on one side. So the second step that we want to look at is, do I have all of my variables on one side and my numbers on the other? And I do. I have all A's on the left and I have all numbers on the right. So once we have everything separated, variables on one side, numbers on the other, or constants, that's when we start breaking up into groups. So if I have 11 A's, I actually want to know 1A. I don't want 11 A's, I want 1A. So I'm going to break up these 11 A's into 11 groups. If I break up the left into 11 groups, I have to break up the right into 11 groups. Divide each side by 11. So if we went back to the hanger, if I want to find out how much 1A is, I'm going to break these A's up into 11 groups. If I break these A's up into 11 groups, I need to break the negative ones into 11 groups. And it works out nicely that 1A and negative 1 match up in a group. right? I can match those up, can match those, right? So every A has a -1 to match because I broke them up into 11 groups. And then my final answer is A equals -11. Now, number 3. Same type of thing that we're going to look for. Can we simplify anything on either side? And if I look on the left, I have 6 R's here and 6 more R's here. I have one negative, but there are no other numbers, so I can't really do anything with this -1. But I can combine my R's. 6R plus 6R is 12R. Combine like terms. One thing to keep mind of and be careful of, I have a -1 or a -1. Make sure that you remember to bring that down. Don't leave that out. Number one thing that students do that mistake-wise is forgetting what's happening with operations and what signs. Okay. So now what we have a little bit different from number 1 is in number 1, I had all of my A's together on one side and all of my numbers on the other. So it was really, really nice that I had that all, set up. But in this case, I don't. I have R's and constants, R's and numbers. So again, once we simplify, our first goal is to get all variables on one side and all constants on the other. So that means this -1 needs to go so that I can get my R's on the left. If I'm subtracting 1, it's like I have a -1. So to eliminate that -1, I have to add 1. Add 1 to each side. Now, I definitely want you to copy down the steps that you did. When you do these on your own, you won't have to, but I want you to copy these so that when you're reviewing and trying to do the problems on your own, you have something to refer back to. So once I add 1 to both sides, I'm left with 12R equals 11 plus 1 is 12. So this adding and subtracting type step is what we need to do to get all of our variables on one side and all of our constants or our numbers on the other. So now once I have that happening, now I'm going to break my variables into groups. I want to break these 12 R's into 12 groups, because if I break 12 R's into 12 groups, I'm left with a single R, right? 12 R's into 12 groups is R. If I divide the left side into 12 groups, I need to divide the right side into 12 groups. Divide each side by 12. 12 divided by 12 is 1. Number 5. I'm not going to do number 5 because number 5 is very similar to number 1. It's just that the M's are on the right instead of the left, but the process is still the same. Okay, so now let's look at number 7. Same type of process that we've been doing. Looking to see if we can simplify. So looking for simplifying first. On the left, I have 37. Nothing's going to change there. I can't really do anything there. Now on the right, Be very, very careful, because when you simplify, you have to follow the order of operations. So when you simplify, you have to follow the order of operations. Be very careful. Okay. So when you simplify, you have to follow the order of operations. So, let me do this instead. So when I look on the right-hand side, I can't do anything in the parentheses because I have an X and a 6. When I come out, I've got a 5, and I have -3 being added. If you try to add first, you're going to be wrong. We have to multiply first because we're following the order of operations. 5 times x is 5x. 5 times 6 is 30. Distribute 5 first. Now that we've distributed the 5, this actually looks very similar to the problems we had on the front, where the left, one side still has nothing I can do, but if we look over on the right, I have a -3 and a 30. I have constants that I can combine. -3 plus 30 is 27. There are no x's, so there's nothing to combine with those 5 x's. But I can combine my constants. Now this looks like the last couple equations we've completed. So our next step is to get all x's together on one side and all constants on the other side. So on the right, I have x's. On the left, I have a constant. So this constant 27 here, I want to eliminate it from the side with the x's. If I have 27 positive, if I want to get rid of them, I need to subtract 27 or combine with -27. Oops. So -27 on both sides. 37 and -27 make 10. Double check that you eliminated those, and then we get equals 5x. Now, hopefully at this point, you know what the solution is going to be. You should know that x equals 2. Some of you may have even realized x equaled 2 up here, and that's okay. You still need to do this work because there will be a point where you're not going to be able to figure it out mentally, and you need to know what to do. If you do it in your head and skip the work, eventually, like in the next day or two, it's going to break down and you're not going to know what to do because you haven't practiced. Okay, so at this point, I have x's on one side, constants on the other. So now I need to break up my 5 x's into 5 groups because I eventually just want one x. So I'm going to divide 5 on each side. Or you can think about this as multiplying 1/5. Right? That's going to come in handy later. And x equals 2. Number 9. Now for number 9, it's actually easier than 7. So again, the first thing we want to do is see if we can simplify. Now, starting with 9 is where we actually have 2 options. So just like the examples that we've seen of the equations that we've been solving and that we've seen solved, sometimes there's more than one way to solve. So we're actually going to complete this 2 different ways. So I'm not going to write the explanations on the side. We're just going to do straight work. So split this up into 2. So the first way, we're going to simplify first and work it out very similar to what we've been doing so far. So I'm going to distribute the 6 first. So let's recopy that down. And I'm going to distribute the -6 first. -6 times 1. -6 times -5v. Don't forget, minusing a 5 is the same as having -5. -6 times -5 is positive 30v. So by distributing, I simplified, and now I've got numbers and variables on the left and numbers on the right. So I want to get just v's on the left and just constants on the right. So this -6 that's hanging out over here, we're going to eliminate by adding 6. Remember, if you imagine the hangers, I have 6 negatives hanging out here. To get rid of 6 negative hangers, I need 6 positive, or excuse me, to get rid of 6 negative pieces, I need 6 positive pieces. Okay. Those add up to 0, so I'm left with 30v equals 54 plus 6 is 60. Now I have v's on the left, constants on the right. So these 30 v's, I want to break up into 30 groups. Because if I break the 30 v's into 30 groups, I'm left with a single v in each group. If I divide the left into 30 groups, I divide the right into 30 groups. And I get 60 over 30 is 2. V equals 2. Now on the right, we're going to do this a second way because I want you to see that you do have options. The only wrong thing to do is if you complete the math incorrectly. You don't follow do one side, do the same to the other, that type of thing. So what I want you to look at here is, see my -6? And then I have 54 over here. 54 is actually divisible by 6. So what I'm going to do is I'm going to divide each side by -6 from the beginning. If you think about it, -6 is being multiplied. To undo a number being multiplied, I can divide it. So to undo the -6 being multiplied, I'm going to divide the -6 out. And I'm left with 1 minus 5v. Whatever I do to the left, I have to do to the right. 54 divided by -6 is -8. Hold on a second. What did I copy down wrong? Hold on. Let me do my division correctly. -9. I knew that didn't look right. Okay, so that's -9. So now I have v's and constants on the left and constants on the right. So I'm going to eliminate this +1. So on the left, I have a +1 and I have 5 negative v's. So to eliminate the +1, I'm going to combine it with a -1. Negative and positive leaves me with -5v equals -9 plus -1 is -10. Now I'm going to have to divide again because now I have -5v's on the left. So I need to divide out a -5 and get v equals 2. Now in this case, completing this a little bit differently didn't really save me any work. Sometimes it will. And you have choices. So I want you to be able to see your options. And that is a mathematically correct option. So I want you to have it that way. You can choose which you're more comfortable with. Sometimes you can kind of go back and forth. All right, our last problem, number 11. This is a big one, but this is actually more like what we've been seeing so far. So we're going to simplify first. On the left, I'm going to distribute the 8. I get 32k minus 32 equals negative 5k minus 32. Distribute the 8. Now at this point, if we look and see what we have, I've got variables and constants on the left, variables and constants on the right. At this point, you get to choose where you go from here, because our goal is to have all variables on one side and all constants on the other side. So if I bring the hanger back for a second, I'm not going to draw 32 of anything, but I have 32 Ks hanging out over here, and I have 32 negatives, and on the right, I have negative 5 Ks, and I have 32 negatives. So our goal is to get all the Ks on one side and all the constants on the other. So you could decide that you want the Ks on the left. So if I want the Ks on the left, I've got to eliminate these by adding 5k to both sides, right? And if I add 5k to both sides here, then I need to take the constants and move the constants over there by adding 32, right? That's one option. Another option, maybe you want the k's on the right. So you would add negative 32k here and negative 32k here. Maybe you want to choose where your constants move. So you actually have 4 different things you can do. You can follow me and the process I do, or you can do what you want. Either way, we come up with the same answer. So I'm going to eliminate my negative 5k's. Sorry. If I have negative 5k, I need to add positive 5k to both sides. I get 37k minus 32 equals negative 32. Make sure you bring all of this down, the negative 32. So if I got my variables on the left, I've got to get my constants to the right, which means this negative 32 has to go. If I add 32, they eliminate on the left, and I actually eliminate them on the right. Even though that's a 0 and you know k has to be 0, we're going to just continue the process for practice. So on the left, I have 37k that I'm going to break up into 37 groups, which means I'm going to divide the other side by 37. And I get k equals 0. And that's it.